So sorry for the first slide. I don't know what it's in. That's the magic of Apple, I guess. So, first some words about myself and this talk. So, I'm a co-founder and security expert at Ninja Lab, which is a small French company based in France. And we mainly do cryptology and side channel attacks and a bit of hardware security in general. And the roots of this talk, it's about a work we published last year about a side channel attack that we successfully performed on the Google Titan security key. And so when we succeeded the attack was targeting the Titan key secure elements and NXP 70005. And so we booked a lot of different other hardware FIDO tokens to check if other tokens were using the same secure element and on which and how many products or attack was working. And so we had a lot of FIDO tokens that we didn't share what we found inside. So that was the roots of this talk. And it's still a work in progress because you have so many FIDO tokens now on the market. So I couldn't buy, I booked some new ones like these last weeks when I was preparing this talk, but it's like kind of something infinite. So my agenda is following. So first I will talk a bit about the FIDO protocol and how the hardware tokens work inside this protocol. Then some teardowns of the authenticators, of the FIDO authenticators that we made. Some other interesting info about other kind of authenticators, and some conclusion at the end. So the FIDO protocol, historically, it's an open industry association now, but historically it has been developed by Google, NXP, and Yubico. And the main goal is to reduce reliance on passwords to thwart phishing attacks. So that's the main goal. We have to keep that in mind, even if we are all like hardware enthusiasts. So the historical goal is to fight like scalable remote attacks. And now you have the FIDO Alliance, which is this open industry association with a lot of members which manage the protocol, the standards. And the concept is kind of simple. It's the use of a second or a strong authentication factor. So it could be a mobile app, a hardware token, and so on. And the specifications evolved over time. So first you add the U2F universal second factor specification, which has been renamed CTEP1. Then the UEF, which works with U2F. And later you add the FIDO2 version with FIDO2 basically is a web authent, which is now W3C standards, and the CTEP2 protocol. So when I began to dig in these standards, it was a bit a mess in my mind. So if it can help some people to not to lose too much time I lost on the web to understand that, yeah, feel free to enjoy. So now I want to talk mainly to what is called FIDO U2F or CTEP1 because it's the protocol which talks to the tokens, to the authenticators. That's the part from the server side, kind of. We don't really care as hardware security enthusiasts. So clearly it's a protocol for communication with any authenticator, and it works in two phases, kind of simple, a registration phase and an authentication phase. So in an authenticator, it allows you to store two kinds of cryptographic key pairs. The attestation key pair, you have one pair authenticator, and the credential key pair. So you have one pair web service. So in your authenticator, you will have one attestation key pair, which will allow to prove that you have a genuine authenticator, and several credential key pairs, one pair per pair web service line, as you can see on the picture. So how works the registration? So first, I forgot to precise that you have three parties involved: the relying party, which is basically the web server. The client, which is kind of in the middle, for instance, the web browser, and your authenticator, which is your hardware token or your mobile application. So during the registration phase, your client, you are on a web page. So the client contacts the relaying party for initiating what they call the registration ceremony. And so the relaying party sends a challenge to the authenticator. The authenticator generates a new elliptic curve credential keeper for this new web service. And the authenticator then sends back the public key, a key handle, which is like kind of an ID of this credential key. It can also contain the wrapped, the encrypted private key, an attestation certificate, and a signature, a cryptographic ECDSS signature, which uses the attestation private key. So once you have the registration ceremony made, so every time you authenticate, it works like that. The client contacts the relaying party for the authentication ceremony. The relaying party sends the key handle and the challenge to the client. So the client sends to the authenticator the key handle and the challenge. It relays that, and it sends the user's presence control byte. You will see later why I prefer that. And so the authenticator signs the challenge with the credential private key, which has been previously created for this web service. And the authenticator sends back the cryptographic signature to the relaying party, which can check the validity of the signature with the corresponding public key that the relaying party got before during the registration phase. So it's a proper the protocol from a cryptographic perspective. And you have also some kind of optional security layers. First, the attestation, this attestation key. What does it mean? In each authenticator, you should have one attestation keeper. So it allows to thwart man-in-the-middle attacks during the registration phase. And it allows also to prove the genuineness of the authenticator to the relaying party. So some authenticators, like bad ones kind of, they use self-signed attestation certificates. So you don't have any proper public infrastructure chain. So, but anyway, and there is a privacy requirement. The idea is to have the same attestation keeper in several authenticators of the same model, of the same brand. The idea is to, if there would have been a specific attestation keeper for each sample, each device, then it will be a way to trace what as a user you do. And so, for instance, on the Yubico website, they explain that they for one model of a Yubico key token, they don't put the same attestation key in all the devices of the same model, but on some batch of like 100K devices have the same attestation key. And they do that for several batches. So, and there is another optional security layer, which is a counter. So it allows to basically count authentications. So the counter is incremented on the authenticator side and on the relaying party on the server side. So it's a way to detect authenticator clones. So if you create a clone of your token, and the web service that you are using is implementing the counter measure protection. So your clone will work, and it will be detected as soon as the genuine token is connected back after the clone has been used. So it doesn't stop the clone attack, but it allows to detect it. So then, as I was explaining in the first slide, there have been a kind of an improvement of the FIDO protocol, the FIDO 2 version, which is basically the web authent part from the between the client and the server, and CTAP 2. And what is the difference about CTAP 2 with CTAP 1? It allows passwordless authentication. Because in FIDO 1, you still had to enter your login, your password for your Google account, for instance, and then plugging your FIDO token. to get the 2FA protection. Now with FIDO2, you can choose to have like just a strong one-factor authentication with your FIDO authenticator, or you can still have your two-factor authentication with your authenticator user presence when you press a button on the token, or you can even have like some authenticators with PIN or biometry and so on, so you can do multi-factor authentication for services that you want a really high level of security. And of course, the U2F CTAP1 specification protocol is compatible, is still in FIDO2. So you can still in FIDO2 do the old way with the login, the password, and the FIDO token. So some words about the cryptography signature algorithms used in FIDO. During the first version of the protocol, you could only use ECDSA signature on the NIST P256 elliptic curve. And in FIDO2, they added a lot of different, new different signature algorithms. So you have to agree on a common supported signature algorithm during the registration phase. And so you have ECDSA still on the NIST curve, on the SecP, on the Bitcoin curve also. You have the EDDSA from Daniel Bernstein and Tanya Lang for like the real cypherpunks know them, I guess. And you have also two kind of RSA signatures allowed, and also SM2. So it's the Chinese equivalent for public key cryptography, public key signatures. Some words about what is a FIDO hardware authenticator, because an authenticator in FIDO can be implemented in several ways. It can be a web browser application, kind of a web browser plugin. So it's like the cheap way to do that. It can be an application on your mobile phone. So it's a bit better. We will see that later. Or it can be a proper hardware token, like a USB token or a smart card. So basically, a FIDO hardware authenticator is kind of the most secure form of authenticator, and it has several potential communication interfaces: USB, NFC, Bluetooth, or contactless smart card. And the minimum requirements, you need a device with a communication interface, of course, some cryptographic capabilities for the signing stuff, and some non-volatile memory to store some data. So some words about the attack surface on these FIDO hardware authenticators. So you can imagine a relay attack if the authenticator is always connected to the client. For instance, if you have an USB token and you let it always connected in your computer, because in the FIDO protocol, it's the client which chooses the user presence control byte. It means that if I can, as an adversary, I can hack your computer, this computer, for instance, and the USB FIDO authenticator is always plugged. If I can execute some arbitrary code on the computer, I can communicate with the authenticator, and as I can fake the clients, I can craft messages saying I don't need any user presence. You can use the don't enforce user presence and sign. So you just ask to the authenticator to sign the challenge, and you don't need anyone to push on the button. So it's a targeted attack, but a real attack is still possible conceptually. And then you have the evil maid attack, so where the goal will be to extract the credential private key of the web service that you want to access, and basically to clone the authenticator. So in this case, you require to have a physical access to the FIDO hardware authenticator during the time to perform your attack. So that's why it's an evil maid attack scenario. And so you have several attack paths. You can try to attack via the software interface of the software attack via the communication interface. You can do some physical cryptanalysis, so side channel or fault attacks during the cryptographic signature. And you can also try to extract the firmware with any technique that you can manage from software people to to this kind of attacks like Olivier was showing us this morning, really, but in a really limited time frame, because if you steal the authenticator to someone for a few hours, it's kind of complicated to go to the invasive attacks lab and to perform kind of micro-probing or so. Yeah, that's something which is not so easy. That's why like a kind of a basic side channel or fault attack can be more portable. So you can have your bench, your side channel bench in your hotel room. You steal the token to someone of the conference and no. And some generic remarks about the attack surface and prototyping attacks on FIDO tokens. The attestation and the credential private keys, they cannot be exported. It's in the specifications. You have no way to export the crypto keys, even if you are like you just want to legitimately duplicate your token because you want to make kind of a backup. You have no way in the specification to do that. So it means that all your attack that you will do, it will be in an unknown key setting. And Timstar was telling us yesterday that it's kind of a hard attack context when you do physical cryptanalysis. So, and but another remark which helps kind of hackers is like with the passwordless feature of the new FIDO2 version of the protocol, it can make the attack more effective. Because in the FIDO1 version, you had to get the login and the password of the user, and then to, for instance, clone his token. Now you just need to clone in passwordless FIDO2. I just need to clone the token of someone, and then I can plug to his user account in a passwordless way. So, now some words about the FIDO certification. So FIDO now is kind of a well-structured specification, and so you have also kind of several ways to certificate different parts of the FIDO ecosystem, especially authenticators. So they have defined several certification levels. And it's also a bit a mess to find. You have everything on their website, but it's not so easy to get everything. So the different levels are the following ones. You have the functional level. It just needs that you just perform some self-validation on your product, and then you made some interoperability tests. So they organize kind of events during the year in different positions in the world. And in different places in the world, and you can go to an interoperability event with your new product, and you check with other people who have also new products that everything works between themselves. It's funny. So with this functional certification level, you can just put the FIDO mark and logo on your product. Then you have the level 1, so it works for any software or hardware device. And it's just a way to say, okay, it's kind of a serious. Actually, I didn't really understood the difference between functional and level 1. And then you have the level 1 plus. It's just say that you can have any software or hardware, but let's say any software FIDO token, FIDO authenticator, which uses a bit of security like white box cryptography. So you can't. An adversary can't just check the memory and see the crypto key in plain text in the memory. So you have the level 2. So the device must support what they call ROE, so kind of a restricted operating environment, and also the device must support attestation, proper attestation with no self-signed attestation key. And for instance, some examples that they give, it's like TEE based on some ARM or Intel or this kind of TEE, or a software implementation based on Windows 10 virtualization based security, or the same for AMD. So now we can go until level 3, and level 3 it takes into account remote software attack, but also local hardware attacks. So for instance, your product could be, for instance, a mobile application using a global platform certified TEE, or it could be a hardware token, for instance, USB token, with a common criteria certified operating system, at least at the level other than 3, and with some tamper evidence FIPS certification. And you have the level 3+, where it's the same than level 3, but it takes into account also the high-level local hardware attacks, and it has to be built on a common criteria certified secure elements with other than 5, like the highest security level in common criteria certification. And just few words, my feelings about this FIDO certification process. So the pro is like there is a web page with a search engine which is really convenient to find all the products which are certified. But the cons are the certification process is not very well defined. We don't really know, except from these examples that I kind of copied past from their website. You don't have proper documentation on how the certification process works. Also, from a technical perspective, what the labs which are accredited, what they really do, and you have no precise way to identify a product. That's a big mistake for me. So on their web page with all the certified products, you have the commercial names, but you have some companies, they have like 2-3 different products with kind of the same name, so you don't know when you buy something, you don't know, it's hard to find the correspondence. And you have also no formal certificate, like kind of a proper PDF where it's written this product with this ID has been certified to this level. So I think they could improve that to copy a bit what common criteria usually do. So now some partial teardown about some authenticators. So first, Yubico. Yubico is a founding member of the FIDO Alliance, and their historical product, the YubiKey Neo, is this one. So XU, which is a kind of old company working on embedded system security, used to publish some years ago this teardown. And so you can see that there is 2 chips, one NXP LPC general purpose microcontroller for the communication, USB and NFC, and another chip, a secure element, an NXP R7005 secure element, which is actually NXP P5 secure microcontroller. So NXP P5, it was the first family of NXP secure elements. It was also called Smart MX1. Now NXP sells the Smart MX3 generation of secure elements. And this Smart MX1 family of secure elements was common criteria certified EL5+ with Avavan 5 until 2015. As now it's kind of a discontinued product, they don't apply no more for certification of this product because they have new ones. And for the known attacks, we will see that later with the Google Titan key. But this product, this token, this YubiKey Neo from Yubico is now no more sold by Yubico because they have a lot of brand new products. So you have the Series 5 family, and you have several subfamilies. You have the YubiKey 5 series, YubiKey 5 FIPS. Of course, they are FIPS certified. YubiKey 5 CSPN. CSPN, it's a French certification managed by the ANSSI, the French cybersecurity agency. And CSPN means certification of first level. So basically, to have a product CSPN certified, you have to pay accredited lab, and the lab has something like 25 days of pen test, and that's all. And they can do kind of what they want. And so that's a way to say there is a lab who has been paid during like a big month, and it's a way to check like the not too complicated attacks on a product. And you have also a bioseries with a biometric sensors to add a layer of authentication. So they are all based on the Infineon SLE78 secure elements, which is kind of one of the best stars of the Infineon product line. this microcontroller, this secure microcontroller is kind of well known for deep hardware attack guys, or especially laser attack guys, because this secure microcontroller has two CPUs which work in a mirrored way, and the idea was like if you inject a laser fault, for instance, as the code is executed on the two CPUs, every microsecond or every 10 microseconds, something like that, the two CPUs check that they are still in the same state. So it was an expensive way to add a big layer of security against fault attacks in general, and especially against laser attacks. So it's a really good microcontroller, which also has an USB interface, USB capabilities. So with only one chip, you have the communication feature and the security cryptographic feature. And this chip is certified EL6 Plus with Avavan 5 as a security level, so the highest security level in common criteria. It's still mainly used by a lot of smart card vendors in biometric passports, in credit cards, and so on and so on. So yeah, it's a good secure element. The product, all the YubiKey 5 series, they are U2F and FIDO2 compliant, and they have the FIDO certification level only level 1. I don't know why, because I think they could apply for the 3 or the 3 plus certification level, but and the casing is really hard to remove. So you can see on this picture. So I tried to open the devices and to put them back in the case, so you can have the name of the product. But it was not so smart because there is with the light and the transparent plastic, it's not. But anyway, for instance, this one, it's a pain to open just to get just to read the package marking, because it's strong plastic. So I use a hot air gun with a scalpel, and it's kind of dangerous for your fingers. So yeah, that's really good products, and for me, really well secure. And yeah, I have just one thing, but we will talk about that at the conclusion. Then the other big player about hardware FIDO tokens is Google, who created the Google Titan Key, which was historically only released for Google employees. And later, Google decided to sell it on their Google Store for everybody. They even have a program for people with specific jobs, like if you are a human rights journalist or stuff like that, and you travel a lot, and sometimes you have to use computers that you don't own. So going to your Google account, your Gmail, for sending the next press article about some sensitive subject with a login and a password in a computer of an hotel is not good. So it was a good way to say, look, buy this product. So you have 3 versions. That's basically the same product, but with different communication interfaces. So on the left, you have the micro USB, NFC, and Bluetooth. In the middle, the USB Type A and NFC, and on the right, it's the USB Type C version. The casing can be easy or hard depending on the version. For instance, the one on the left, it's really easy to open with a scalpel, and then you can open it, do what you want, and reclose it easily. And it's if you are like meticulous, nobody will notice. But the two others, it's hard. It's you need the hot air gun. You destroy a bit the casing. So if you want to perform the evil maid attack, then you will have to perhaps 3D print a new casing to open the device, to make your attack, and to plug back the PCB in a new casing that you created. So it's kind of complicated to do. And about the teardown, when you open it, and you can see on the PCB that the hardware is actually made by Feitian, which is a Chinese company. And all the versions of the Titan keys are made on, based on the same architecture. The chip for communication is an NXP LPC microcontroller, and secure element is the NXP 7005, the same than in the old Ubico, the YubiKey Neo. And strangely, the Titan key is only U2F certified, not FIDO2. At least it's what is written on the FIDO website. And they just have the certification level functional. With, once again, they could apply for a higher certification level. Perhaps it's kind of something new, the different certification levels in the FIDO specification. So, and the known attacks, you have two attacks. Microsoft Research published an attack in 2019 about a relay attack which was exploiting a bad Bluetooth configuration. The concerned products have been recalled and it has been patched by Google. And last year we published our side channel attack on the NXP secure elements. So which was like your evil-made attack, where you need like kind of an access of 10 hours of the token. You had to perform a kind of complicated side channel attack with a bit of equipment. And this attack has not been patched by Google and NXP because it's like this kind of secure elements, you can't update the ROM and the crypto libraries easily. So, yeah. Now Phytian. So Phytian propose FIDO security tokens for end users, but also in white labeling. And they propose generic FIDO security keys with customization for casing, packaging, related services. So the casing, it's like for the Google tokens. It can be easy or hard depending on the product. And you can check that this one really look like to the Titan key. Or so this one, and so you have a lot of Phytian products. So the one we opened, you have all these different products. I will go fast. You have all the details, but what is interesting is some of them you have only one chip for communication and as a secure element, which is a Nation Z Z32 hub. So it's a Chinese IC manufacturer, and they claim to have kind of a Chinese common criteria certification. But you have no info about that on the web. At least, I should perhaps learn a bit of Chinese, but, and, it's also, a lot of them are also FIPS certified. So, for instance, this one is a product which is really which is kind of similar to the Titan key. This one, you have, still only one chip for both communication and security. It's the same than this one, the Nation Z, secure microcontroller. This product is also really similar to another version of the Titan key. And on this one, they use the Nation Z secure element as a chip for communication, and they use the NXP A7005 as secure element. So sometimes they mix. They have some fun at Phytian, I guess. And this one is a version with biometric capabilities. So you have a chip for biometry, a Sino chip. Which is used, I guess, for biometric checking. And you have one chip for communication and security, the same Nation Z microcontroller. Some of the products, like this one, we didn't figure out what was the chip. We thought it was a Nordic semiconductor with this model, but it's French. And also on this product web page, it is claimed that secure element is a common criteria EL6+, but I don't know that Nordic was applying for common criteria certification. So, and on this one also, we just found a package marking Infineon, MTH, blah blah blah, and we couldn't find anything on the web linked to this package marking. So if some experts have some insights, we are open. So we also booked some products from Trustkey, which is a South Korea company. Seems kind of a startup in security. All the products are based on the same architecture. They use for communication a Nuvoton microcontroller. As a secure element, they use a EWBM secure microcontroller, which is actually EWBM is a South Korea fabless startup. and we didn't find any certification information about these secure elements. And all the casings are really open with really easy to open with a scalpel. So that's the account. So here you have the list of the different devices we opened. Nothing really crazy. And also we booked some Newave products, which is a French startup company. And the different products, they are all based on the same architecture. The chip for communication and secure elements, it's a WISE-Key secure microcontroller, which is Common Computer certified at the highest level. Actually, WISE-Key, it's perhaps some of you used to know in Atmel, you had a smart card division making the old Atmel secure chips. And this division has been sold to Inside Secure, which is a French company. But later, Inside Secure sold this division making secure microcontrollers to WISE-Key. So basically, the WISE-Key secure microcontrollers correspond to the old Atmel secure microcontrollers. But it's good, and the chip the chip is has also an USB interface and USB stack, so it's cool. It's kind of like the SLE Infineon SLE 78, and also the casings are kind of easy to open with a scalpel and without damage. So some words on other interesting authenticators that I found on the web. The BSI has published a Common Criteria protection profile about FIDO authenticator. So it's quite interesting to see that now in Common Criteria they also take account the FIDO authenticator as a product. And they also published on GitHub, BSI on GitHub, they published a Java card applet for an FIDO authenticator. So you can take any open Java card and load this Java card applet. And they even made a project with GND, which is a German famous smart card vendor. So and this smart card from a GND, which is Common Criteria certified with the BSI applet, has been Common Criteria certified to the highest level. And it's also certified at the FIDO level 3+, and that's the only product I found on the FIDO website, which is certified at the level 3 or 3+. And it's not actually a product, it was a project, but you can't buy it. You could buy this Java card from GND and load by yourself the applet. But if you tell that to your company to do that, it's strange. This product is just a like a prototype. I think perhaps if we contact GND, but I didn't find any business web page from GND with this product that they could sell. Also, Thales Gemalto. So this company is historically really known as the name of Gemalto, but now it has been booked by Thales. So I will say Gemalto because I'm nostalgic. So historically, it's a French smart card vendor, and it was the worldwide biggest smart card vendor in the field. They sell really highly secure products. They are really famous for that. And so they have 3 different FIDO tokens. 2 of them are smart cards, and based on the Infineon SLE 78. And one is a USB token. And the package marking is this one, and we couldn't find any information about this package marking, and there was no logo of any IC manufacturer. And all at least 2 of them are certified, Common Criteria certified, and one is only FIPS certified. And this smart card, which is interesting, is like the chip. The Java card operating system and the Java card applet are all Common Criteria certified. So for companies, this product is really cool because it's fully Common Criteria certified at the highest level. So it's a good choice, I guess, for governmental organizations or. And a few words about the most famous hardware cryptocurrency wallet companies. Ledger. Ledger has an official FIDO application that you can load on your Ledger Nano S or Ledger Nano X. So you require your device PIN to register or authenticate during the FIDO FIDO procedure. You can back up your FIDO credentials with the BIP39. That's the way in the Bitcoin world to back up your seed for all your cryptocurrency accounts. And FIDO 2 will be soon supported, what is written on their developer webpage. And in the Ledger products, the secure elements, that's ST secure elements, ST31 or ST33, and they are both certified common criteria at the IGES level. And for Satoshi Labs, which is the company making the Trezor's hardware wallets, you have also an official FIDO application, and they are already both FIDO 2 compliant. And you can also use the classical way of the Bitcoin world to back up your seed, to also back up your FIDO credentials. The only con about Trezor products is that they are based on STM32 microcontrollers, which are really nice microcontrollers, but not so secure. So against hardware local attacks, it's not the best product. And some words about other big players. Apple now supports in different ways the FIDO protocol, and now you can use your iPhone or your MacBook with Face ID or Touch ID as a FIDO authenticator. It's kind of convenient, and they iPhones and MacBooks, they use the Secure Enclave coprocessor in the E device or the M device now as a secure element. So, and Secure Enclave is known to be a strong security coprocessor, so it's cool. And with Google now, with Android 7 and later, you can use your smartphone as a FIDO 2 authenticator, and basically it uses the Android key store attestation and device TEE as a secure element. And so you can in both products you can use your device biometric to authenticate. So it's cool and convenient. So now the conclusion. So how to choose a good FIDO authenticator? Of course, an hardware one. Huh? We are hardware IO. To choose one with a casing hard to open, and hard to replace is a good way to add a security layer against local hardware attacks. To choose one with a secure element which is common criteria certified at the IGES level is also a good way to be protected against hardware attacks, at least at some point, huh, Olivier? And an architecture with two chips for me is perhaps better because it adds a security layer against attacks targeting the USB interface. So I'm totally not an expert in the USB stack. But for instance, the Infineon SLE78 secure microcontroller, which has an USB interface, I wonder how during the common criteria certification process, I wonder how the labs validated that the USB stack, which can be kind of huge, that there is no bug in this software stack. So it's a good question how we can assess this level of security about USB stack. And a product with a PIN or biometry adds another authentication factor, but it's security. It will be less convenient to put the biometry or to tap the PIN every time you want to authenticate to a website than just plug in your token. So you have more security, but it's less convenient. It depends on the application, I guess. And some words about the future. It would be nice to see some FIDO authenticators certified at the IGES levels, like the FIDO level 3, level 3+. I guess like the Yubico products, for instance, deserve to be certified at this FIDO level. And also, why not some FIDO hardware authenticators, which could be common criteria certified following the BSI protection profile. So now that common criteria as a way to certify FIDO products, it would be nice. Okay, common criteria certifications are expensive, but could open some market for governmental agencies and so on. And I'm just wondering about other potential attacks, attack paths on FIDO hardware authenticators, like attacking the USB interface or USB stack for single chip FIDO tokens. So as I was just saying, USB stacks, you have interruption, parsing, blah, blah, blah. So it's a huge attack surface. So what about fuzzing or software combined with fault injection attacks? It would be nice to see people trying to do that. And also, what about fault-based cryptanalysis on the ECDSR signature? Or now that in FIDO2 we have also different kind of signatures, RSA and so on. Why not to, it would be nice for next year to have this kind of attacks. And that's all for me. Thank you for your attention and for staying for the last talk.